Here is graphing a quadratic function in standard form. The first chart here shows you two different parabolas. The one on the left opens upward, so it's going to have a minimum at that vertex point. In the equation, f of x equals, it's going to be a positive ax squared. The second one that opens downward, its vertex is going to have a maximum. And when we have the function, it's going to be a negative ax squared. So we call this concave up, and this one concave down. The caution sign over here says the minimum or maximum value is the y value of the vertex. It is not the ordered pair. So when we ask you for the max or the min, give the y value. Here's an example where we're going to go ahead and graph all of the important pieces to this quadratic function. So we identify the a, b, and c value. So this is the a, b, and c in standard form. Now, what do we know about the graph? We know that this is concave up because our a is a positive number. So our parabola is going to look like this. And then it's going to have a minimum at that vertex point. The parabola is also going to be the same as its parent because the a equals 1. So there's no multiplier in front of that a, so it's not making it narrower or wider. The last thing is the vertex will be having a minimum point because it opens up. So we'll have a minimum at that vertex point. So let's go ahead and find the axis of symmetry. So we're going to use that axis of symmetry equation, negative b over 2a. So we substitute in. Negative, and then we sub in the b, negative 6, all over 2. Substitute the 1 in for a. Then we simplify it. Negative negative is going to turn that to a positive 6. 2 times 1 is 2, and then we get 3. So the axis of symmetry is x equals 3. So then let's go out and graph that line of symmetry. And then label it. The vertex will always be the x-coordinate of the axis of symmetry. So we know the vertex will be at 3, and we want to find the y-coordinate of the vertex. So to find the y-coordinate, we evaluate the function for 3. So we say f of 3. And we substitute that in for x, so we replace the first x with 3, the second x with 3, and then we simplify it with our orders of operation. So 3 times 3 is 9, negative 6 times 3 is negative 18, and then we add and subtract left to right. So we get negative 9 plus 3 reduces to negative 6. So we do want you to write this vertex as an ordered pair, 3, negative 6. And then let's graph it. So we're going to go right 3 and down 6. This will be the minimum point on the graph. The next thing we want to do is we want to find that y-intercept where it crosses the y-axis. So we are going to evaluate the function for 0. So we say f of 0, replace the x with 0. So 0 squared minus 6 times 0 plus 3. When we reduce that, we get 3. So just like the vertex, we want to write the y-intercept as an ordered pair, so 0, 3. So then we go up and graph it. And there is our y-intercept, which crosses the y-axis. The nice thing about the green line is we can then create a reflection point that goes 3 units to the right from the y-intercept, because that line of symmetry is about. Now we have 3 points that we can then connect to create our parabola that opens up. So this ordered pair here is 6, 3. This one is 0, 3. And then that minimum vertex point was 3, -6. We can also find additional points if we want by evaluating the function. Step 5 says find the maximum or minimum value. So that's going to be that y value. So if we look over here, this is our y value. So that's going to be our minimum. Lastly, we identify the domain and the range. So the domain of every parabola is always all real numbers. The range are your y values. So if we look over here on our graph again, the y values start at -6 and then everything higher than that. So here's -6 and then everything above it. So we say our range of values is y greater than or equal to -6. Example 2, we want to go ahead and do an application problem with a quadratic function in standard form. So you can go ahead and pause and read. What I like to tell my students to do is if you're not comfortable with the variables m and s, you can change that function to a x and y. So I'm just going to change that to y equals -0.025 x squared plus 2.45 x minus 30. What we're going to do is we're going to find the vertex. And the vertex represents the speed of the vehicle and the mileage of the vehicle. So that's your x and your y. So we've already done some problems where we find the vertex by opposite of b over 2a, and then we substitute that value in. So let's first find the speed. So to find the speed, we're looking for the x of the vertex. What is that number? My pen is not working here. So we do opposite of b over 2a, just like we do the x of symmetry. So this is our a, and that's our b. So we substitute it in. We get -2.45 all over 2. Replace that a. And then we simplify it. And we get 49. So what does that mean? So the speed of the vehicle is going 49 miles per hour. The second thing it asks for is the mileage. And the mileage is going to be miles per gallon. And we want to round it to the nearest tenth. So that is going to be the y coordinate of the vertex. So to find the y coordinate, we evaluate the function for the axis of symmetry value. So we say f of, and we substitute 49 into the function. And then we use our calculator to simplify it. And we get 30.025. So we want this answer to be to the nearest tenth. So here's the tenths place, so 30.0. And then the unit of measure is miles per gallon.